Geometry. We are asked in a circle, so we've got our circle geometry. We have our circle theorems, which are 9 of them. Please read what's on the side of the sketch, because sometimes there's something on the side of the sketch that's not on the sketch, and then you miss that piece of information. They did say that K, I'm not sure what this was, PR. They said that PR or PKR or RKP is a tangent. So I must make sure I know I'm going to be using the tangent theorems. How many tangent theorems are there? 3. 3. Of which the second one, the part yet, can't be there because there's not 2 of them. So that's out. So what is the first thing that jumps to mind though? Tan chord theorem to me most of the time. But then also, number 7, the radius is perpendicular to the tangent. Doesn't mean 45, 45, right? And then the tan chord theorem would say that between the tangent and the chord, now the tangent and the chord, K1 is the tangent and the chord being equal to which other angle then? Where must your fingers go? If it's K1, it's between tangent and chord what? VK. Going to which side? U. So U what? U. The whole of U, which I don't have. So it's not 48. Are you with me? Yes. But the whole of it, whatever it is, I don't want to make too many marks here, the whole of it will be equal to P1. So it is going to be there. I know it is. Okay, but let's go from theorem 1. Theorem 1 says line from the center, perpendicular to a chord. It's not going to a chord at all. So theorem 1 is not there. Theorem 2. Yes. Which is? Angle of the center twice the angle of the circumference. Yes, I think so. But I don't have it yet.
You do.
But I do.
Yes, you do.
Where?
So,
With that 120, can you see it angle at the center?
Yes.
Does that make this 240?
No. The other one.
That one will be 240, and that would be a method of using. That would be 240 because it's the squished in one. Isn't it maybe also angle at the center squished somewhere else?
Yes.
No, that I'm not seeing. Angle at the center squished somewhere else, I'm not seeing. Are you with me?
Yes.
Then we've got bow tie. I'm not seeing a bow tie. Okay? Then we've got cyclic quads. Is there a cyclic quad?
Yes.
Yes. And the cyclic quad is? V-U-T-K. Meaning that if this is 120, 60, because it's not equal, right?
Yes.
And this is the first question. So they're kind of like leading you into it. So V would be equal to 60 because of angles of a cyclic quad. Look at your reasonings, guys. Look at your reasonings. And that would be worth 2 marks. Then they're asking me for KOU. KOU is that one. Well, now that I've had it, see them leading me, scaffolding. So once I've got that 60, I can have this one, which is 120. Would you have gotten 120 using, if this is 120, that is 240. And then for a revolution, it would still be 120. Perfect. You have an extra step, but it's perfect. No problem. So if I go according to what they gave me, then KOU would be equal to 120 because of, what did I use? Angle at center of the circle. Twice angle at circumference. Right? And then they're asking me for U2. What's going on here? What's another thing to always keep in mind when you're in circles? Radii. Because the radii will often, very often, give me isosceles triangles, which you never write as a reason. So this is an isosceles triangle. That means that both of them are 30. Okay, and equal. First of all, I got to 60 because I'm adding the sum of the angles of a triangle, so I'm short 60. Meaning the because it's an isosceles triangle. So can I just say U2, and I can even say K3 is equal to 30, and my reason is what? So get that answer immediately. But what's my reason?
Everyone's opposite.
2. Is it 2?
Animals opposite equals side.
Yeah.
And interior angles of the triangle.
And she also said radii. There's actually 3 things you should say. It's the sum of the angles of a triangle, or interior angles of a triangle. It's also angles opposite equal, and why are the sides equal? Because it's radii. Now, if you wanted to first say OU and OK are equal because of radii, that means that those two added together is 60 for the interior angles. That means each of them is 30 because of angles opposite equal sides, and written them in 3 lines like that. It's fine. But don't miss out on the reason if you put them all together. Okay, then they want K1 and they want K2. Now remember, if you wanted to do it in a different order, are you allowed?
Yes.
Say for instance, you could find K2 from the start, and you do it, but you write there, I'm first doing 11.5, doing that, and then I get to the answer there at the end, I'm going to just say 11.5, already done. Are you with me? You can swap it around, but clearly label which ones are you busy with, because it's not set in stone that you've got to do 11.1, 11.2. In a question paper in the matrix, they give you the answer sheet, so it is there 11.1, 2, 3. But if you do it squished around the other way, then you must just relabel and say this is 11.1, here's 11.2, here's 11.4, there's 3, etc. Are you with me? Yeah, but it has to, whatever you do, follow upon each other. You can't use something there that I've already said in question number 1, but you haven't proven it yet. So they're asking for K1 and 2. Obviously we know that they are 90 together. Doesn't mean 45, 45. So how can you do that? Who's got a technique? Who? With the tan chord theorem we said what? Tan chord equal to the whole of. So that means 78. Because the angle between the tangent and the chord is equal to the whole of this angle, which was 78. Are you with me? What else could you have used in the other class they said? Can I not get K2 first? Using, interior angles of this big triangle. So I've got 60, I've got 78, I've got 30, so I'm short something. And get that first. And if you've got it, can you not then use the 90 to get to the other one? Are you with me, guys? You can do the second one first, etc. I want to emphasize that to you. You don't have to do it in this order. If that's what you saw, big triangle, adding them together will give me K2, some of the angles of a triangle. Then what? Obviously that would have been 12 if I'm right. Because they have to add up to 90. So if I didn't have the 78 from here, how would I get the 78? Because the radius is perpendicular to the tangent. That's why it would be 78 then. So you did it the other way around. If we do go for K1 then first, K1 would be equal to
78.
You have to write it this way. It's good principle, good methodology to say it's going to be equal to the two of them there. Because say now your U2 was wrong. We have to go and follow up, but now you're telling me I'm adding them together. My answer is not right because I worked it out wrong, but it's there. I can see the connections because of. And somebody wrote in the test just chord theorem. That's not right. Tan chord theorem. It's abbreviations, but it's got to be right. Okay, and then for K2, how do I get my K2 then? Can I now also still use the interior angle of the triangle? Yeah? I would like to use, so it's a fact that the radius is perpendicular to the tangent, right? If I didn't use it, is it okay? Yeah? But I'd like to use it just so that we can remember it again. So I will say that K2 is then 12 just because of what? Tangent, perpendicular to radius, and normally we say radius perpendicular to tangent. Is that a problem? It's the same thing. We know it as tangent perpendicular to radius. So it doesn't matter if you swap it around, and we've got our answer. Each of them. 2 marks, 2 marks. This one might have been more marks because there's more reasonings. That's too much. Okay? To get to your answer. Another geometry problem to solve. Please remember to read everything, because there was something on this sketch there was something next to the sketch that wasn't on this sketch. They said that O is the center of the circle. They usually give it away with that big dot, but you can't assume. They have to tell you that it is the center of the circle. So that means that, and they told me that AOC is the diameter as well, which actually you should be able to see. And if it's a diameter, there should be something popping immediately behind it. Angle is a semicircle because of the diameter. That's worth a mark in the sum for sure. But together that adds up to 90 because of angle in the semicircle. You've got 2 marks whether you know what to do further or not. Are you with me? You see the stuff once you've practiced it. They told me that this was 33 degrees, and they said that COA is perpendicular to DB, which is not on the sketch. If it's perpendicular, that means all of those are 90 degree angles. You don't have to do it like I've done it. You can just do one little piece. But it's given that it's 90. In words, not on the sketch. And if you just looked at the sketch, you would have missed that. Okay? Then the questions are, find A1. Now A1 sits there. Ideas. Let's go through our theorems. Line from a center, perpendicular to a chord. I think it can be there, but do I have the lengths? Because then usually, if I say that this is 30, then you'll know that that is 30 as well. Or the whole length is 80, then it will be 40, 40, something like that. I've got nothing given to me in lengths of sides. I've got the 90, it's given. So maybe later, but not at the moment I'm going to use it. It's a fact that if it's perpendicular, it will bisect. Okay, second one, angle at the center twice the angle of the circumference.
Yes.
Is it there? Yes, where? This O, let's make it O1. It's the squished one. Where? B? 2. Excellent. Are they equal to each other though? Angle at the center is twice the angle of the circumference, but if you weren't looking for it, you wouldn't have seen it.
Oh,
Do you see it now?
yes.
Angle at the center subtended by AD going to the center, subtended by AD going to the circumference. It's one of those that's on the same, but it's squished to the side. You see it?
Yes.
You'll only see it if you look for it. It's one of those. Okay, angle at the center twice the angle of the circumference. There's the center on the same chord going to the circumference. So whatever the one is, the other one is half of it, right? But I don't know either one of them at the moment, but there's something going there. Is there another way maybe that I can use angle at the center twice the angle of the circumference?
Yes. Yes. Oh.
Which one?
Oh, it's 2 times B1.
This whole piece here would be this half of V1.
Yes.
Are you with me? But they haven't even called something, but it's there. Keep it in mind. The semicircle we've already done.
Yes.
Bow tie we said. No, we haven't said. Have we said? No, I don't think so. Bow tie.
There is.
There is. Where?
There are like 2.
D1 and C.
And also,
It's so squished apart. Not a nice bow tie. It's like, but it's there. You see it?
yes, ma'am.
AB going to C and going to D1.
Oh.
But it doesn't pop out at you. You've got to look for it.
Yeah.
AB going to the angle of the circumference. AB going to another piece of the circumference. There's the bow tie.
Yeah.
You see it?
Yes.
Okay. It takes practice to see it, but you're looking for your theorems. So bow tie we've done. Cyclic plots?
No.
Not that I can see. And 7, 8, and 9?
No.
If there's no tangent, you don't look for them.
Interior angles in the triangle.
Interior, I was just going to say. So, beside that, what's always in a question like this with circles? Radii?
Yeah, there is.
Where?
D and OD and OC.
And how's that going to help me?
Then we're gonna D2 is equals to C.
Mm-mm. Then you're going to have a triangle here. OD and
OA.
OA. You see it? You see the triangle with radii being equal? Meaning that A1 and this whole thing here would be the same. It is an isosceles triangle. Two sides, that angle, okay? And what else? Interior angle of a triangle you see. And parallel line, oh, okay, there's no parallel lines. But all the other stuff that you've been knowing forever. Interior angles of a triangle, is that going to help me?
Yes.
How?
We're gonna find A.
A2. But they're asking A1. Oh, just wait, let's get there. Okay, let's see. Maybe we go this way. Maybe somebody goes shortcut way. Doesn't matter. We're seeing it as we go along. So if that is 33 and this is 90, then this would be 57. Okay?
Oh.
What else?
A1 is 57
A1 57. Why?
because of interior angles.
Of which one?
ADE.
ADE. Okay, so did we need that 57 just for a second? Let's erase that. To get directly to A1, could we have done it? Yes. Because it's still 90 that we were told, 33 that we got with a bow tie,
Right.
and then that'll still be 57 with the sum of the angles. What does that mean for these two triangles? They kind of like look like they are congruent, right?
Congruent.
The angles are the same, but it's just angles. There's more than angles. There's sides as well, if you wanted to. But are they asking me for congruency?
No.
So don't go on a mission that there's not. Okay. Let's have a look. So A1 is done. Shall we write it?
Yes.
Where did we get there? How did we get there?
D1 is equals to
We said that D1 was equal to C because of
angles in the same circle segment.
angles in the same circle segment. And then we knew that E1 was 90. Now guys, you don't have to write it because it was given. But maybe just because it wasn't actually given on the sketch, I'm saying, okay, I know it is because it's given. And that's why A1 will be 57 reason.
Interior angles of
The
triangle.
interior angles of a triangle is what? 80. How many marks? They told me there. No, they didn't tell me there, did they? Yes, 3 marks. Most probably that because it's the grade 11 work. It's more with more marks. For the 90,
No.
for the 57 and the reason, 1 mark. So if you didn't write the reason and you got this right, you don't get the mark. Okay. Second one. Let's get to D2. Now, if you've done what we've already done previously, we know that this is a isosceles triangle. Meaning that's 57, I'm shorting 24 to get to 57. But it's done now. But if you didn't look and see the isosceles triangle, the radii that are equal to each other, you've missed it. Then you think, where else can I go? Well, was that the only way of doing it? Definitely not. Because angle at the center I could have found. Could I? I could have found it with this. And if I had 57 there, I'd have 33 there, 33, 66, and I could have done some of the angles of a triangle. Other ways of doing it. Are you with me? But I like to always remind you of the isosceles because it helps 99% of the time. So we're going to say for D2, how are we going to find it? We said D2 is equal to 24, just like that. But your reason must tell me all this stuff. Why is it 24? Because it has to be equal to 57. Because of? You can first say interior angles, then say radii, then say angles opposite equal sides are equal, or we can state angles opposite equal sides, and radii, and some of the angles of a triangle, but you've got to have all of them. Some of the angles of a triangle is 180. Actually, it's first the angles of a triangle, then that is radii, and then that is angles opposite equal sides, but it's fine like this. Okay, so we've got our D. Huge work, and it looks so easy peasy.
It's not.
And that was worth, how many marks? 2. Only 2. So it's everything or nothing. If you had alternative means of getting there, 2 marks has been allocated, even if it's 4 steps longer. Last question, they're asking me to prove that AE bisects DAB. What are they actually asking me? AE bisects DAB. So what are they asking me? Prove that A1 and A2 are the same. That's what they're actually asking me. Why are they the same? Then I've proven that it bisects. Different way of asking. Prove it bisects, meaning prove that the angles are the same. So what do you need to get? Because I've got A1 long ago. Now I only need to find A2. How?
Then we said instead of angles of the triangles.
With which one?
With ACB.
ACB, excellent. But only that. Because you're losing a mark. How do you get to the 57? You're using the 33 and you're using the 90, which you haven't said a word of. It's there, but you haven't said it yet. That angle B1 and 2 is 90 because of an angle in a semi. But remember, that's worth a mark. And then you don't have to say it's 33 that's been given. If you want to, you can. And that means that A2 would be 57 because of the interior angles of?
Triangle.
I think there's so many triangles, maybe we should say triangle ABC. It's good measure, it's good technique. Alright, so A2 is that. Oh, am I finished?
No.
So it doesn't answer the question. That means that A1 and A2 are both 57 because I've proven it, no reason needed. But answer the question. AE does bisect DA. Please answer the question. You've actually done it, but answer the question. Right. So the next 2 for the next time.